Okay, the recording got interrupted at the very end of that video. I asked you to complete this one on your own and check your work. Well, here's that solution. Now, the decimal result off the calculator extended forever, so we know that this is a non-repeating, non-terminating decimal. And at the thousandths position, we saw the number 5, but looking next to it, we noticed that that value was large enough to round this 5 up to 6. So I like 6.856 as the solution here. Now, as we progress, we start to see these indices, or an index that's provided with the radical. And this time we're looking for a number that multiplies by itself 3 times in a row to equal 512. And we could sit here and guess and check, but I do allow calculators for most of this class, so we'll go to it. Now, in order to use that command, we cannot use the square root symbol anymore. We have to use what's called the nth root and provide the index. So I'm going to press Control and then this key just to the left of the one that we had been using. That's going to call the nth root command. And so now we have a spot to indicate our index. This time we'll use the number 3 as the index and use our cursor to jump back inside the radical symbol and evaluate that at 512. Now when I press Enter, I see the result is 8. And the answer is 8 here because 8 times 8 times 8 will equal 512. Clearly 8 times 8 is 64, and apparently 64 times 8, which is a little bit large for me to do in my head, will equal 512. So what about number 9? Can we take the cube root of a negative number? Is there such a thing that multiplies by itself 3 times in a row to equal negative 1,000? And as it turns out, the answer is yes. 10 times 10 is 100, times another 10 is 1,000. So what happens if all of these were negative? Well, the negative 10 times a negative 10 gives us a positive 100. And that positive 100 times a negative 10 will give us our negative 1,000. So unlike square roots, or even roots for that matter, we can take the cube root, or an odd root, of a negative value. So even without using the calculator, we've reasoned that the cube root of negative 1,000 is negative 10. Certainly, if you were unsure of your result, you could use the calculator to determine it. So now the work starts to get fun, and one technique that I'd like to share with you is that it's entirely permissible to break this radical into 2 parts. So if we wanted to find the cube root of negative 64 and then the cube root of x to the 21st power, that's perfectly fine. That's a property of radicals that does hold true. So let's think about this first group for just a second. Is there a number that multiplies by itself 3 times in a row to equal negative 64? Well, as it turns out, yes, there is. And if you're familiar with this number, you'll recognize that 4 times itself 3 times in a row will equal 64. And if we use a negative 4 times itself 3 times in a row, that will also equal negative 64. And if you'd like confirmation, here it is in the calculator. Cube root of negative 64 is negative 4. Okay, so that's a good answer for the first term. What about the second term? Is there a number, or in this case, an exponent, that multiplies by itself 3 times to equal x to the 21st? Now, when we were dealing with square roots, we were just looking for the half, or 1/2 of this 21. If you have an inkling here, because of this index being 3, we're looking for 1/3 of 21, you'd be correct. 1/3 of 21 is 7. In other words, 7 times itself 3 times in a row. 7 times 3 is equal to 21. So if we were to add 7 3 times in a row, we'd end up with 21. And that would be the proper procedure here, because this number, this one, and this one are all the same. When the bases get multiplied together, the exponents were added. So the simplified result for this section is simply going to be x to the 7th power. If we were to check our work and multiply negative 4 times x to the 7th 3 times in a row, we should recognize that, or following our techniques from last week, that the coefficients multiply together. Negative 4 times negative 4 times negative 4 is negative 64. And the exponents multiply together. Especially with like bases, those combine nicely. X times x times x requires us to add the exponents, which does return x to the 21st. So I'm happy to say that negative 4 x to the 7th would be an appropriate solution for this particular question. Now, the difficulty of these problems does seem to be increasing, but I think you can still handle this. Let's recall some of the steps that we've been working on so far. First things first, with this negative symbol out front, we can treat that as a separate component of this whole problem, and we'll handle that after we handle the interior work. And then also, I'd like to remind you that the cube root, while it could be separated in the prior step, we could split this problem up into two cube roots. We can do the same thing with fractions as well. So I could find the cube root of z to the 21st power and divide that by the cube root of 8x to the 6th power. So with all of that in mind, let's try to tackle this guy first, this one at the top. Now that's going to look pretty familiar because we saw a problem almost exactly like it in the last step. We had x to the 21st, but this time we've got z to the 21st. So the cube root of z to the 21st power, again, is going to be z to the power that's 1/3 of this value here. So we'll call that 7. 7 plus 7 plus 7 would be 21. So if I were to multiply those terms together, we'd get back to z to the 21st power. So I like z to the 7th in the numerator. Now in the denominator, let's think of this as two pieces again. Is there a number that multiplies by itself 3 times in a row to equal 8? The answer is yes. That's the value 2. Is there an exponent that multiplies 3 times in a row to equal x to the 6th? Keeping in mind that whatever we choose requires the exponents to sum together to equal 6. So in this case, 2, 2, and 2 would be good. And if you recall that shortcut we were starting to mention in the last step, we're looking for the value that's 1/3 of this 6, which happens to be 2. So as far as this component in the top goes, we end up with z to the 7th power. And as far as the bottom component goes, we end up with 2 times x to the 2nd power. And all of that is technically being wrapped with this grouping symbol and the minus sign out front. So I believe that would be fine as an answer. There shouldn't be any trouble in reporting this. So I would suggest that you try that in MathXL if you have a problem that's similar to this. Otherwise, what you could do is you could distribute this minus sign into the fraction. Now keep in mind that the distribution technically only goes to one of the sections, either the numerator or the denominator. It does not go to both. So if I were to report this, I usually distribute that negative sign to the numerator. I would say negative z to the 7th over 2x to the 2nd power. And that's another way that we can report this answer. But I'm fairly certain MathXL will accept this one, and you don't have to go through the trouble of distributing. In number 12, I'm going to recall that this negative symbol is going to be done after we simplify the root. And I'm looking for a number that multiplies by itself 4 times to equal 256. Well, we could guess and check, or we can use the calculator. I'm just going to use the calculator here. And we'll look for the 4th root of 256. And that ends up being 4. If I wanted to include the negative symbol at the very beginning of this problem, I could have. But let me remind you that the negative symbol is this key. Don't use the minus symbol or subtraction symbol. When we press enter, the result ends up being negative 4. So while the 4th root of 256 was 4, a negative 4th root of 256 is negative 4. Again, using our calculator for practice here, we want the 5th root of the number, whoops, let's try that again, fifth root of the number negative 1024. And we will get an answer here because this is an odd number index. So an odd number index can account for this negative symbol inside the radical. And that answer comes out to be negative 4 as well. How interesting. Lots of negative 4s and lots of 4s as a result here.